Hi everybody, I am Matt from Ref, it's an MCP server. You might also have heard of it as Ref Tools or ref.tools is the URL. Super excited to be here. Super glad you are all still here. You've been listening to talks for 8 hours in a row. That's kind of wild. I can't even watch Netflix for that long. So appreciate you being here. Hopefully you enjoy it. And I hope you learn a little bit about MCP Sessions and Agentic Search. If you haven't heard of Ref is it's a startup that the entire product is an MCP server. People are paying a subscription for that. They're paying to use this server. It's a documentation search server for coding agents. So Ref will index public docs and private docs and give your agent access to those. It's if you imagine your agent never making mistakes working with libraries, either public or private libraries, and doing that in a way that it doesn't blow up the context window. So Ref allows your agent to go find just the snippet of documentation it needs to be successful and not pull in a bunch of other junk and other tokens. My goal for this talk is to pop the hood on Ref, talk about how we achieve that, and then how we use MCP Sessions to build a really precise and token-efficient documentation search. The way I want to do that is first I want to talk about search evaluation. So I'm saying we're going to build a really good server. I want to first talk about how we measure that. Then I want to talk about different approaches. I want to talk about a basic approach and then a more advanced approach to a server like this. Then I want to layer in MCP Sessions. So we'll talk about what are sessions. You may have heard about that in some talks earlier today, but we'll do a little refresher. Then we'll talk about how Ref implements them and the features we implement on top of sessions. Then we'll talk about what has been the impact in production. This has been out for a while. We'll see what the actual gains have been. We'll also talk about some of the challenges along the way, some of the issues we encountered and had to overcome on this implementation. And then we'll close with a couple action items for you all. How does that sound? Thumbs up? All right. Yeah, I appreciate the enthusiasm. That was way more thumbs up than I expected. All right, let's get into it. So to start, we're going to talk about search evaluation. The first thing we need to do is define the search problem. So search is when we have a query, we have a bunch of documents, and we need to find the documents that are relevant to this query. The classic way you would evaluate that is with two metrics, precision and recall. Recall is, did we find all the documents that were relevant? And precision is, of the documents we chose to return, which ones were relevant and which ones are not relevant. So ideally, the perfect search is we're finding all documents that are relevant, and we're only returning documents that are relevant and nothing that's irrelevant. This is the way you'd evaluate the classic Google search, go in, put a query, get your 10 blue links, see how well you did. But at Ref, we're building a search system for agents, for coding agents. So we actually iterate on this metric a little bit. We use recall and token usage as the metrics we're evaluating the system by. The reason for this is we want metrics that evaluate the entire search process. And when we think about the search process, we start to think about how humans search and how agents search and how that's similar and also different. So if you imagine yourself, the classic human search experience is you go to Google, you type in your query, you get 10 blue links, you kind of skim over them. One looks good, you click into it, oh, it wasn't right, you back out, iterate on your query a little bit, and you do this sort of iterative research approach. It turns out that agents do basically the same thing. If you observe Claude Code while it's working, it will follow the same pattern. This is actually kind of similar to Richard's talk on the tool, I'm blanking on the name of it, but the tool discovery pattern, where the agents will sort of do some research and iterate and figure out what they need to do. And this is how we see human search, and it's how we see agent search. But that's how they're similar. How are they different? Well, how human search and how agent search are different in terms of the sort of active working context. So for a human, when you're searching on Google, your active context is that browser tab you're looking at with those 10 blue links. And that, like, so the scarce resource you have as the search provider is the human visual field of I'm looking at these links. The human is trying to scan through them and find what's relevant among those links. And so precision is a metric that measures how much of that field of view is being taken up by irrelevant stuff, because that's sort of wasting that space. For agents, the working context is the context window. And that sort of builds up over time as we do this series of searches. And so there's this different behavior where as search results return, they're staying in the context window. And we care about how much of the context window are we taking up over the course of the search. Oops. All right. Over the course of the search procedure. And the reason we also care about this scarce resource of context window is, one, tokens are expensive. We all know inference costs money, and so the more just irrelevant tokens we're throwing into our context window, you're just wasting inference, wasting money. And we also care about it for context rot. The team at Chroma had a good paper about this. If you haven't read it, I'd recommend checking it out, where as the context window grows, as the amount of context grows, the quality of generation sort of slowly turns over and declines. And this is something we see sort of across the board. And I think it really also matches the experience we as developers have, where you're working with Cloud Code or Cursor for a while, and you get to a point where you're just I got to start over. It's not getting it. And so we really want to be very efficient, with our documentation search server to find just the pieces we need and not be filling it up. So at Ref we evaluate search with recall and token usage. So yeah, now we've talked about the problem. We talked about how we're going to evaluate solutions. Let's talk about some of the solutions. First, we'll talk about a basic solution, and then we can talk about some of the issues with that. So the classic search API is this function from query and a number of results or number of tokens you want to a list of chunks. This is kind of like the classic RAG that we've all been doing for a couple years now, where you go fetch some stuff and you just throw it in the context window and you count on the model to sort of figure it out. And it often does. Models are quite good at taking a bunch of stuff and figuring out what's relevant. And these typically work in a way where they either return a certain number of documents, so 10 documents, or documents up to a certain number of tokens, so maybe 10,000 tokens worth of documents. And you're going to put them in the context window and sort of count on the model to use that effectively. So if we look at that and we compare it to what we were just talking about how agents are iterative in their search approach, and about how we care about the amount of context window we're using, you start to see some things that just don't quite line up. There's sort of an impedance mismatch there. The first one that's obvious is we're just putting a bunch of stuff in context, and also we care about using as little context as possible. And that kind of begs the question of, can we do better? The next part of that is that the agents will search iteratively. So if you're going to use this approach, where you're putting a bunch of stuff in the context window, and the agent realizes, oh, my query wasn't quite right, let me iterate on that. This is an observed behavior. We know they'll do this. You're going to get a whole nother big chunk of stuff in the context window. So every iteration is very costly in its approach. So let's see what we can do better. The better approach that search servers, not just Ref, but Ref, implement are these two tools, a search tool and a read tool. The search tool will return a list of URLs and maybe a description. In Ref's case, you'll get a URL linking to a chunk of documentation plus a description, and a read URL that allows the model to choose which pieces of documentation to pull into the context window. And in Ref's case, it can actually on the fly read any URL, sort of go scrape it for you on the fly. And you can see how this tool spec fits more with what we see the agents actually doing with their iterative approach of searching and reading. We also know that the model providers are training the models to do this, because this is the deep research spec. So if you want your MCP server to be a source for deep research, you need to meet this spec. And so Ref does, so you can use it as a source for deep research. Great. So now we're going to evaluate with token usage and recall, and we're going to use this tool approach with a search and a read tool. let's bring in MCP Sessions. This is kind of the thing we're talking about here is MCP Sessions. At the highest level, MCP Sessions allow you to have a stateful server. So they connect the state on the client to the server. Going one level deeper, the way that works is when the client initiates a connection to the server on a new transport, the server returns a MCP session ID, then the client hangs on to that, and with every future request, it includes that session ID, and now the server can say, okay, all of these requests are related, I can store some state and use that to do something. So yeah, MCP Sessions allow for a stateful server over the HTTP, the streamable HTTP transport. So there's more nuance. If you've seen some talks earlier today, you might already realize there's more nuance to that. We'll get into that later. But at the high level, what we're looking at is how can we use sessions, the statefulness, to build a stateful search experience. So in Ref, what pieces of state can we include? So if we look back at those tools, we can see the pieces of state that our server can store are, we can store the queries, like what is the agent actually searching for? We can store the search results. What did the search server return? What have we passed back to the agent already? And we can store the URLs that the agent chooses to read. So let's talk about some of the improvements we can implement based on storing that state. There's going to be 3 of them. The first one is prefetching. So we know what search results, what URLs we've sent back to the client already. It's very likely the agent will choose to read one of those URLs and not like some other random URL. So we can prefetch those, have them ready to go in cache. And so it's a little snappier, a little faster. That's great. I mean, we're all engineers. We love optimizing things, making things faster. But I want also, for the sake of transparency, this doesn't actually help with our metrics around recall and token usage. It's just like kind of a nice thing, a nice side benefit. So let's talk about the token usage improvements. The first one is we can choose to just never return the same link twice. We know over this iterative search process, everything we've returned is still in the context window. The agent can go back and choose to click a link from a prior search, which is like different from how humans search, right? That'd be like if you have all of your browser tabs open next to each other and you're like, oh, that wasn't right. Let me go back to my other tab and find the links. That's just not how humans work. But for agents, we're building up this context window. Here are a bunch of links. We know you already have it. And this gives us the benefit of just not putting repeated stuff in the context window. Like if you are searching for something, you get the same link a few times in a row. In the human world, that's fine. But in the agent world, we're just wasting tokens. This has a second benefit in that if you think about this iterative query approach where the agent is refining the query, it's like, does one search, maybe it adds a few terms to the query and searches again. What the agent is really doing there is kind of paging through the result space. So it's like it's shining its flashlight, it's like got some results, and then it's like, okay, I need to like adjust it a little bit to try and find what I want. And so we're sort of paging through results. If we were to return repeated links, that paging process is much slower. So if you imagine we return 8 links the first time, and now we return another 7 links, but only one of those is a new link, or 2 of those are new links. Now we've returned repeated stuff, but also our ability to page through the space is slower, so we need more loops for the agent. So this cuts down both on repeated stuff and also the looping aspect. Something else about Ref, this is maybe like a separate tech talk, I'm going to just put it in a box on the side here, is that Ref also implements precise search. So if you remember, I talked about the search where we have like an n query param, where you're saying, I want n documents. Ref doesn't have that. It doesn't say, you don't specify how many documents or how many tokens you want. That's up to the server to decide based on the query. So we can try and return either return maybe 2 for very precise queries where you're like, I want this specific API, the parameters of this specific API, versus like a query where you're saying, I want best practices in React. That will give you a bajillion results, and the server will choose to return that many results. This fits nicely with this approach because you're sort of paging and you very quickly, like the server will return fewer results as the agent continues to page and search. So you like very rapidly narrow down to the set of things the agent needs, and eventually it wraps up quickly. But that's maybe a separate tech talk about how we implement that. Cool. All right. The third improvement is on-the-fly extraction. So one of the risks with the search and read approach is the agent can choose to read any URL, and it doesn't know how large that page is. It doesn't know how much it's actually asking to bring in, and it could choose to read a page that's very large in its entirety. So, for example, I used to work at Figma. I helped build the REST API there and write the documentation. It's all one page. If you convert that to Markdown, it's 90,000 tokens. There's no way you or any LLM actually wants that in the context window. You really wanted like one small piece of that. But this is kind of like a landmine this approach has, where you could bump into a URL that is like very large. And so what we want to do is, like, as we're returning results, recognize, oh, this is going to be too large. We don't want to return all this stuff. Let's figure out what the relevant parts are and only return those. So what we can do with ref is we have your query history. We have what the agent is searching for. And so we can use that to, on the fly, chunk up a large document and then return the chunks that are relevant and still not do any summary, but still return the actual source text up to a certain token limit. And that's really effective for not accidentally stepping on one of these landmines that would just explode your context. This is kind of similar. I think Firecrawl and there's some others that have extract tools where the agent will prompt, say, here's a URL and maybe a schema or a prompt that's like extract information. This allows us to have that capability, but keep the tool definition simple with we have search with a query and read with a URL, but we get this more advanced capability because we've stored this state. Cool. So those are the three improvements we implement with MCP Sessions. Let's talk about some of the actual like hard numbers of what actually do we see in the results here. So for our eval, we set a baseline of 10,000 tokens. This is a baseline. We need a big round number so that we can say we can have a normalized score of how many tokens are we saving versus this like large goal. We choose 10,000, one, because it's a big round number, and two, because there's another very popular server in this space called Context7. Maybe some of you are familiar with it. It's great. It's a solid server. The way it works is you pick a library and then get 10,000 tokens. So if you pick 2 libraries, you get 20,000 tokens. And this works well for a lot of people, and that's great. But we're trying to see how much better can we do than this very popular server. And it turns out we can do like pretty significantly better. So in the average case in ref, you'll save between 70 and 50% of tokens for popular libraries. And in the best case, 95%, like up to like a ton. That's, to make that more concrete, that's 500 tokens instead of 10,000. And in dollars and cents, that's 8 cents, or over here it's 6 pence. So very real, both in terms of context rot, of like a smaller number of tokens versus a large number, and like a very real like dollars and cents saving. So that's great. Let's talk about some of the challenges along the way there. There's maybe one big challenge that I would sort of describe in 2 ways. It's the combination of client fragmentation and the fact that this session ID is at the transport layer of the protocol and doesn't really map to a logical session. So what I want as a developer is I want to know, as a server developer, is when the user and the agent agree we are in a fresh context window, I want my server to also know we're in a fresh context window altogether. Unfortunately, because this lives at the transport layer, the lifecycle of the session is up to the application developer on when they choose to initiate the connection to the MCP server. So some examples for that are the command line tools, so Codex and Claude Code. You run the command line tool, it starts a new fresh session, and it initiates a transport, and so you have one session. And it actually does kind of match what we want, where you have like one chat, you close it down, and that's one life cycle of a context window. There are some edge cases where if you like clear the context window or you or compact it, you're in a fresh context, but there won't be a new session ID. But it's mostly there. It gets hairier once we work up the chain to the IDEs, so Cursor and VS Code. Although I learned today that VS Code improving in this respect from Sean's talk. They initiate the transport when the app starts and when the user changes the configuration of the MCP server. So if you're in Cursor and you're doing a sequence of prompts, you do one prompt, you get your generation, you're done, you start another chat with the agent, all of those will share a session ID because they're on the same transport. What that means, it's still you can still use that, or ref and ref does, but it requires a little bit more defensive programming to handle these edge cases and different ways clients implement sessions or implement their own lifecycle. The funniest one is ChatGPT Deep Research. It implements all of the steps, it implements the protocol completely, but it initiates a new transport with every single request. So we actually lose out on all this stuff, unfortunately. Even though it does properly open and close and do everything correctly, it does it every single request. So, but there is some light at the end of the tunnel. I think this SCP has been mentioned before, and I encourage you to check it out around making MCP stateless. It's going in a really great direction towards having more logical sessions and also more scalable sessions. I think this is also really interesting to me as I'm a startup developer. It's just me building this one thing. So my priorities are here, and then Curtis, for example, works at Google, and he's talking about how do we deploy and manage deployments of these massive deployments of MCP servers. And it's really interesting to see this sort of one proposal bring things to a cleaner place that really supports the whole ecosystem. So I suggest checking this one out. Cool. So that's mostly the talk. I really hope you learned. I hope you learned about a couple things. First, I hope you learned about how to evaluate agentic search in terms of recall and token usage as the more appropriate metrics. In particular, I think that the takeaway there is, as MCP developers, we need to be looking at what do humans do, what do agents do, how are they similar, and also how are they different, and then really leaning into that as we're developing our servers. Yeah, and I hope that's what you take away in terms of building a good search server, or any MCP server really, is this process of really going deep on how do agents use a service like this. And then third, I hope you learned a little bit about MCP Sessions, and I hope this has prompted the question of what state could you add to your server? How could you use something like this in the server you're developing to really go one level deeper in terms of providing the best possible experience for agents? And to close, I just have a few actions for you all. Just 3. The first one is to engage with me. I'm a solo developer. The biggest problem I have is just getting the word out. So, and I post content like this and my stuff and about ref and whatnot on Twitter and LinkedIn. So really connect with me, chat with me there. I'd really appreciate it. Anything that helps boost the word. The next one, I don't know if anyone in this room actually can help me with this, but I'm going to put it out there. And if you can, it would make my day, absolutely. Every developer tool that is an MCP client has a page of here are pretty good MCP servers, high quality servers for developers. I would like to get ref on as many of those as possible. So if you manage one of those pages, or someone who does, and hopefully from this talk you took away that ref is a high quality server for developers. If you're open to making a warm intro to somebody who works on one of those pages, that would make my day. And number 3 is, this is by far the easiest one, is just come say hi. I crawled out of my cave in Northern California and flew all the way here to chat with you all. So, and it's time, we're gonna go to the pub. So yeah, come say hi. I'm very friendly and look forward to chatting with you all. And yeah, thank you so much for being here and sticking it out.